So the purpose of this lesson, lesson 32 for this particular video, is to show you how to take a probability density function, turn it into a cumulative distribution function. In this case, we're going to need to complete the square for this arbitrary PDF, and then in order to be able to invert the CDF. From there, we'll use the inverted CDF to produce numbers using R from that particular distribution. So that's the idea behind this lesson. So if I were to give you a density function that looks something like this, where maybe 8 is the smallest number that could possibly come out. Oh, and this is going to be a triangular distribution. And then maybe 14 is the max number that comes out. And this is a triangular. So there's lots of triangular distributions, but this particular one, we're going to say that most of the distribution, or the density of the distribution, lies around 14, and then an 8 is the smaller part of the density. So most of the time 14s come out, and then very infrequently the 8s are smaller numbers. So this, I mean, we could have made it been the other way, but this is just the one that I chose. Okay. So the question here is, what is this line, right? So that's the very first thing you got to figure out. So I'm basically giving you 2 points. And the one thing that we do know is the area underneath in this triangle has to equal 1. So delta x here. So if this were, let's see, yeah, we'll use x. So delta x here, 14 minus 8 is 6. And this is a right triangle because it's going straight up. Hopefully it looks like that way. The question is, what is my height here, right? So if I know area is definitely going to equal 1, and that's equal to 1/2 base times height. In this case, base is 6, and I don't know h. So we can simply solve for h, and it looks like it is going to be 3, maybe 1/3. So it's equal to, so we solved for this. I'll just put it in a different color. We solved for it, and it's equal to 1/3. So if that's equal to 1/3, then I can start putting in the points that I know. So I know this is going to be 14 comma 1/3. And this, we already knew this point. It was 8 comma 0. And then the question is, well, what is this line? Really, because that's what we need to find in order to be able to do this arbitrary distribution. We'll say f of x. So this is my PDF, and so that's why I'm using little small f of x. And what is f of x equal to? So first we can just find the slope. So the slope is pretty straightforward. M is equal to delta y over delta x. We already know delta x is 6, so we can go ahead and throw the 6 on the bottom. Oh, and delta y is pretty straightforward as well, as 1/3. So we know m, our slope of this line, is going to be 1/18th, even though it's not drawn like that way. Obviously 1/3 would not, if this were drawn to scale, it certainly wouldn't look like this. Okay, so now I need to find a function that does this. So point slope, what is it? Yeah, point is, so I know the point, I know the slope. So y minus y naught. Okay, so let's use this. Let's use 8, 0 as my point. So I'm going to use the point slope formula in order to find our line, because we know that it might not look like a line, but it is. So y minus 0 is equal to m, which is 1/18 times x minus 8. So that is the line. So y, or f of x, really, that's what we're shooting for. We're shooting for that f of x. So we're just going to say f of x is equal to 1/18 times x minus 8. And you can put in the points just to make sure. If you put an 8 there, you're going to get 0. You put in 14. 14 minus 8 is 6. 6/18 is 1/3. So we get the numbers that we're looking for. Okay. The next thing is, well, so I have my PDF. So my PDF, so f, so let's write that. PDF is, just by using a little bit of knowledge about what a PDF has to be, the area underneath the curve equals 1, and that this is a triangle, and we know that some of the things that go along with a triangle. So when we do a PDF the PDF is 1 over 18 x minus 8. So we have that. So now I want to find, so I'll do this in another color. We'll do it in green. So now I'm looking for the CDF. We want to find the CDF of these things. Why? Because like I said in the intro there, the purpose of this is to find the CDF and then invert it in order to start producing random variates of this thing. So f of x, capital F of x, is equal to the integral. Well, here let's write in what we're talking about here, right? So this would be x, and that would be the probability up to that point is what we're looking for. So this would be f of x. Here, let me draw it, or at least write the probability statement. I know you guys may or may not be tired of me. So if this is a random variable, tired of me writing this probability statement, is less than or equal to some small x, where this and this are the same, right? So that's the number that you're going to put in there. And the way that we find that is the integral. So this is probably an easier way, or an area way to find this thing, but I'm not going to concern myself with that because the integral will find it regardless of what that function is on top. So we're going to go from the smallest 8. Oh, I forgot to put this. So this is for x between 8 and 14. So that's how I know where to, that's the limit of my integration down there. And then I'm going to go up to some particular x, and we're going to integrate that line, that 1 over 18x minus 8 over 18. Ooh, I kind of messed up there, right? So for those, I give you guys garbage for, we got to put a dummy variable in here. Why do we put a dummy variable in here? Because you can't have a limit of integration, have an x in the so here. So this would have be a limit of integration. You can't have that and an x in here as well. So this dummy variable will basically integrate out, and it'll just leave us x dy. So now we're sitting in a position where we can do our integration. Let's see, so it'd be 1 over y squared, 2 on the bottom, will leave us 36. And then minus 8 over 18, that would leave us with a y evaluated from x to 8. 8 over that, and then we do our substitutions. So now we're putting in the x in, and we get 1 over 36x squared minus 8 over 18x, and that's by substituting the top number in, substituting the x into this thing, and now I'm going to substitute the bottom number and subtract it. Everyone remembers hopefully their integration things. So 8 squared over 36, and then minus 8 over 18 times 8. Okay, so all I did was substitute 8 in to get this second part. And if you simplify this thing, it turns out to be it's 1 over 36x squared. So all I'm doing is you go to your calculator, you put these things in, and you'll get this. And we still have the 8 over 18x. And then if you put it all in your calculator, you'll get 3218. 32 over 18. And this is also good. So this is true. Okay, so if I were going to write this thing out, right, I would have to include, so if this is a true CDF, we would have to write it out like this. So f of x is equal to, well, it's 0 up until we reach 8. So when x is less than 8, it's 0. And then when we get to 8, you start accumulating probability according to this equation. X squared minus 8 over 18x plus 32 over 18. And that is going to be true when we're between 8 and what is the number? 14. 14, and then 1 if x is greater than 14. Okay, but there's a problem, right? Because my next step in this situation is I want to invert this thing, right? So inverting this thing is how we're going to start producing random variates. And the way that we're going to invert it is I'm going to set u equal to my CDF and then solve for x. So u is equal to this thing in the middle there, and then solve for x. Well, there's a problem, right? Because this equation is not easily solved for x. Not easily. So what we want to do is we want to take that part of the equation and I want to invert it. I'm sorry, I want to complete the square. So I want to do something to that thing that's going to make it easier for us to invert. So I'll just write this here. Matter of fact, let's go ahead and change colors back. So we want to make the equation easier to solve for x. So that's the idea. And the way we do that, so I'm going to take the one in the middle. So let me just make sure that we're talking about, when I say the one in the middle, I'm talking about this thing right here, and I'm going to complete the square. Okay, so before I talk about complete the square, I'll do it on the side over here. I have to do this and complete the square. I don't remember this crazy. It's not crazy, man. I just don't remember this formula. So I'll just show you some of the things that I do to remember what it is that you have to do in order to complete the square. So I'll just basically write a couple squares, right? So x squared plus 4x, because it's two of those, plus 4. So that's true. And then x minus 3 squared. So again, I just arbitrarily just chose a couple of these and write them out. X squared minus 6x plus 9. And then maybe one more, I don't know, x plus 4 squared is equal to x squared plus 8x plus 16. I mean, this isn't rocket science here. What we want to do, so if you were given just this part, the part to the left, in other words, if you're just given that, what do you have to do to come up with that number is the question. And so if you think about sort of what we did in order to get that number, you take this, whatever is on the x, and you divide it by 2. Right, because I ended up being 2 of those and two negative 3s, and here, let me get my cursor here. There was 2 of those because it was 2 times x plus 2 times x, and then it was a minus 3x minus 3x, so there was 2 of those, and there was 2 of those. So all I have to do, and then what are you going to do to that? Well, you're going to square it, right? So all you have to do is take whatever's on the x and divide it by 2, and then square it. So 4 squared would give us 16. So 4 squared gives us 16, so we're good. Same thing here, if you took negative 6, divided it by 2, you get negative 3. If you squared that, you would get 9, which is exactly what we want there in order for that square to be complete. And then if you, so just so you remember, whatever it is that's inside this little thing squared is what's going to be, so for example, this would be x plus 4 quantity squared would give us this entire thing. So whatever this 8 minus, so whatever this thing divided by 2 is, whatever that thing divided by 2 is what goes in here. Whatever that thing is divided by 2 is what goes in there. So there's 2 things you got to kind of get from completing the square. What number goes over here, and then what number goes inside your square. Okay, so taking all of that into account, here I'll put it into a purple color now, completing the square. So we want to complete the square of our middle term there. And our middle term, so I'm going to take a 1 over 36 out of that thing. So that would leave us with x squared here, because I didn't talk about the beginning of the things that would go on the front of these. So I'm just not going to have 1. So 1 over 36, and then if you multiplied 8 over 18 by 36, you would get, let's see, that 2 left, so it'd be minus 16x. And then multiplying that one by 32, I'd have 2 and a plus 64. So we'd get x squared minus 16 plus 64, and then 1 over 36. Okay. So we have that. Oh, it looks pretty nice, right? Because now I'm going to take this. So that would be negative 16 divided by 2 would be negative 8. And if we squared that, we get 64. So I don't need to do anything. So the thing's already a square, so that's pretty nice for us. So we got to remember to keep our 1 over 36, and then we just do x minus 8, right? Because whatever this is divided by 2 is what's going to go into this square term. So we get 1 over 36 x squared minus 8, and so that is this equivalent to what we have right there. So that's a little nicer, at least I think it is, and it's going to be a little easier to invert the CDF. So let's go ahead and invert it. So all we do is we take that thing instead of equal. So when x is between 8 and 14, we're going to let u be between 0 and 1. So u would be equal to 1 over 36 x minus 8 squared. Okay, and now what we're going to do then is multiply both sides by 36. So I get 36u, and that is equal to x minus 8 squared. And then take the square root of both sides, so you get plus or minus the square root of 36u is equal to x minus 8. And then x, so I'm solving for x. So x is equal to 8. And the question is it plus or minus? So 36 times this uniform 0, 1 number. So what a u is, it's a uniform, oops, let me write that a little better. It's just a uniform 0, 1 number. So it's going to be, maybe when it's 1, 36, 6, so 8. So it's going to be minus 6. What numbers do I want again? I want numbers between 8 and 14. So it looks like I want the plus. So I want the plus square root of 36u. So think about that for a second. When u is 0, so there's going to be numbers between 0 and 1. So we take the biggest and the smallest. So when u is 0, I'm going to have 36 times 0. And that'll give us nothing. So 8 plus 0. So that's fine. And that would have worked with the minus. But what happens when you get a plus and the u's 1? When you use 1, square root of 36 is 6, and 8 plus 6 will be 14, and that's where we want to be. We want to be between 8 and 14. And this is only true when and we don't have to worry about this because these are the numbers that we're going to be given, but when u is between 0 and 1, this would work. Okay. So let's go back. Let's go to R now and start producing this. So I'm going to use this x is equal to 8 plus 36 times u, and I'm going to produce a whole bunch of these, and then we're going to do a histogram. So I'm going to produce these using this formula. And then we're going to do a histogram just to sort of prove that it did what we thought it was going to do. All right, so we should see when we do our histogram numbers between 8 and 14, 8 and 14, and then you're going to see it look a lot like this triangle that we want to produce, right? So you're going to see small numbers here, maybe a little bit bigger, and so on and so forth, and it just keeps getting bigger, sort of like this, coming up to 14. This is what we would expect to see. I mean, sometimes they're going to be bigger, sometimes smaller, but we would expect to see this thing have a higher probability of getting numbers that are larger or closer to 14, and a smaller probability of getting numbers that are closer to 8. Okay, let's see if that happens. Share R. Okay, so let's go ahead and produce. So if you didn't know this already, it's runif. It looks like runif, but it's really random variate of uniform distribution. And this means n, the number that I want, I don't know, we'll do 10,000 of them, and this is the min and max, right? So I could have moved this as well, but we'll just do 10,000 of them. Enter, and just to show you what it looks like, we'll just do a quick histogram, right? So right now, you're just getting these u numbers are just all these numbers in between 0 and 1, and you can kind of see they're leveled out, and so they're doing what they're supposed to do. Pseudo random numbers, again, that's what R produces for us. And now we want to convert these to x, right? So now I'm just going to substitute in that equation that we just had, that we just developed using a little bit of math, and I'm going to get 8 plus the square root of 36 times u. And let's see what happens now. Oops. I don't know why the thing did that. So view, zoom in, view, zoom in, control plus. Apologize for that. My hand hit it for when I went down to hit control enter. So control enter, and then hist x. And you can see that you have a higher, so this is the number of these numbers that occurred, and then you can kind of see it looks like that triangle. And we could keep doing u equals uniform or random variate uniform numbers. Do 10,000 of them again. Yeah, you can kind of see. If I did 100,000 of them. Again, the only thing that changed with the 100,000 is the frequency. We'd expect this triangle-looking thing and the numbers to be between 8 and 14. All right, that's all I got for this one. You're going to need this for the project, so just make sure that you understand what's going on here and ask questions if you need to.